Thank you for joining me today here on the Manning Publications stream. I'm going to talk with you today about querying NoSQL with SQL. And the subtitle there, if you saw the little preview video, is all about having your JSON cake and selecting it too. So thank you for joining me here today on this. This is the first time I've done anything like this. It's actually taking over some other Twitch stream. So this is going to be interesting. It's going to be a fun experience, I think. Normally, I stream on my own channel there. You can see at the bottom of the screen, Matthew D. Groves on Twitch, where I don't do usually like slide-based presentations like this. It's very much just sort of hanging out, and I call it office hours. It's just hanging out and coding and discussion and answering questions and things like that. And you can actually go and watch previous episodes of that there on bit.ly/GrovesTube there at the bottom of the screen. I'm going to be monitoring the chat the best I can. Normally, in my stream, the chat appears on the screen. That's not going to be the case here. Wasn't able to set that up completely. I had to change a whole bot and configure a whole bot, so I didn't do that. But I'm trying to monitor the chat the best I can. So if you have questions or comments, feel free to throw them there in the chat. Happy to answer your questions. We've got plenty of time here today. I don't think I have a limit per se, but we're probably going to be around somewhere in the hour to hour and a half range, depending on how many questions we've got and things like that. So let's get right into it, shall we? All right, so consider this example here. You may have used a NoSQL database before, a document database, something that stores JSON. And here's an example of a query language for a popular document database. It's a query, and just looking at it, it's kind of, unless you're familiar with this database, of course, I feel like this one's kind of hard to really read and understand quickly. But this actually, what this does is it will select all documents where the price is 99 cents or $1.99, and the sale field is equal to true, or the quantity field value is less than 20. So now that I've told you that, you can kind of parse through that and kind of see how that works. And that's probably the most popular JSON database right now uses a language like this for queries. However, if you're like me, and I know I am, I have been using SQL most of my career as a query language to work with data, and the Stack Overflow surveys, other surveys bear this out. That's SQL, SQL, however you want to say it, is the most popular language for dealing with data. So wouldn't it be nicer if we could just write a query like this that does the same thing as the query I just showed you? However, it's in that select, from, and, where syntax that you're familiar with, and at the same time querying JSON data that has other benefits that we'll talk about here today. So that's what we're going to do. That's kind of in a nutshell what we're going to talk about today. I've got 4 sections here. The first one, I'm going to spend some time on why NoSQL, because in my experience, not everyone's used NoSQL or really understands why I would consider using NoSQL for an upcoming project or anything like that. So we're going to spend some time talking about that. It's not going to be a completely exhaustive look at NoSQL, but we'll look at some of the sort of higher level reasons why you might want to use that. And then I'll spend some time talking about JSON data modeling, because JSON data is different than tabular data. It's different than traditional relational databases. The way you store data is different. And so we need to talk about that, spend a little bit of time on that. This is not a data modeling session, but I think it's an important thing to talk about first before we dive into the main topic today, which is SQL for JSON. What would that look like? How would it work? How could I actually do that today? And then at the end, we'll take some time for some summary and, of course, questions. I will try to answer those as they come in on Twitch. Since it's Twitch, I usually just read the questions out loud. So we got Vato Death says, yeah, so thank you. I'm glad you're excited to be here. Will Bevan, can't tune in for the whole stream right now, but looking forward to watching this back later. Cool topic. I agree. This is a cool topic. This is one of the things that I like the most. I work for a company that is a NoSQL database company, and this is one of the things that makes me excited about that is SQL for JSON. So I don't know where the videos are posted or when they're posted, Will, but thank you for stopping in for a little while at least, and I hope you can watch the video later. So just in case you are watching this video sometime later, I'm on the Manning Twitch channel right now. Which is cool. Really cool that Manning is kind of embraced Twitch, and I'm very excited about that. You can Right now I'm at twitch.tv/Manning Publications. You can come to this site later. They've got a whole schedule of stuff going on, various Manning authors. I'm actually an author of this book right here, AOP and .NET, which is nothing to do with what I'm going to talk about today. This book was actually published, 7 or 8 years ago, something like that. And I haven't done much stuff in my own career with AOP in about 4 to 5 years. So it's still, I think it's a book. A lot of the tooling in there is outdated. But I think a lot of it will probably make sense, even with the modern versions of the tools I talk about in there, which are still around. The two main ones are PostSharp and Castle Dynamic Proxy or Castle Core. So if you're interested in AOP, I'm not going to talk about it today, but it's a book you can check out there. And I believe there's a coupon code if you scroll down on your Twitch screen. There's a coupon code there at the bottom if you want to save some money on Manning books. There's lots of other great books on there. Excuse me. I'd recommend personally Andrew Luck's book on ASP.NET Core, and of course John Skeet's book on C#. Two of my favorites I'd recommend for Manning authors that are more related to what I'm talking about today, I guess. I'm Matthew Groves. I'm a developer advocate for Couchbase. You can find me on Twitter. Sometimes I post blogs and record podcasts. You can check it out there. That's a link to the book I just mentioned, AOP and .NET. And that's a picture that kind of looks like me. You see the resemblance there? I don't know. This is before I grew any sort of facial hair because I've been staying at home, but kind of looks like me. All right, let's get into it. We're going to query NoSQL with SQL. How is this going to work? Well, first let's talk about why would I even use NoSQL in the first place. And what I want to say right out of the gate is that I really don't like the NoSQL buzzword at all. It's pretty meaningless, I think. And so, for instance, all these databases here on the screen, every single one of these are considered NoSQL. And some of them really aren't like each other at all, right? A graph database is very different from a wide column or a key value database. Key value and document are kind of similar. They're kind of like cousins, but wide column and graph. And there's other types as well that I didn't even list on here. So I don't like to use the term NoSQL to mean something technical. It's just sort of a marketing buzzword. I like to be more specific and say, okay, document or key value. So we're going to focus today mainly on document databases because those are the ones that store JSON. And so there's a few examples of JSON document databases up there. And they're called NoSQL in the first place because you see these operations right here. Those are all ways to interact with the data. By key, basically. You're going to look up a document by key, replace it by its key. And then there's this whole idea of MapReduce right here. This is kind of cool. MapReduce, which is kind of like a query, but not really. But these are all kind of the baseline that all the NoSQL databases kind of had at first. Now, they've matured a lot in the 15 or so years that NoSQL's been around, but these are kind of the baseline that they all have in common. And that's why it's called NoSQL in the first place, because none of those operations involve writing a SQL query, as opposed to the most popular databases in the world that all you need to use SQL to access data in all of them. So why people are looking at NoSQL in the first place? So there's a few reasons. There's, I'd say, maybe 4 reasons. I think the main one originally, and probably still, is scalability. So there's 2 types of scalability. One of them is called vertical scaling, is what you're seeing here. And this is just, you have a database, you need more RAM, you need more operation, you need more capacity. So you take your database machine and you upgrade it to a bigger, faster machine, more cores, more RAM, more disk, things like that. This is maybe the easiest way to scale a database because all you just do is upgrade the hardware on it. And, move your database to a new machine. But the drawback to this is that it can get very expensive, right? I think I saw Microsoft just announce some sort of like 128 core VM available in Microsoft Azure that is in the hundreds of thousands of dollars per month, I think, something like that to run. So, for a large enterprise, a large company, if they want a vertical scale, that's kind of the direction they have to go in. And that can get expensive, of course. And there's a performance ceiling for certain types of queries, for certain types of data loads, for certain types of concurrency. It's just going to hit a performance ceiling. There's a paper on this called, or maybe it's a blog post called "No More Free Lunch," that kind of talks about, okay, the curve keeps going up and up in computing, and we double transistors, that sort of thing, and we've sort of been leveling off recently. And it makes an argument for distributed computing, or in my case here, we're talking distributed databases. And what's a distributed database? Well, this is what is referred to as a cluster, or might also be heard as horizontal scaling. So instead of one big machine, I have several machines, and they could be big machines too if you want to, or they could be inexpensive, low cost, lower end machines. And I put them all together in a cluster, and they all communicate with each other over a network, so they're able to share data with each other and perform updates and replications and things like that. But as an application, I access them as sort of one thing. There's just a cluster that I'm interacting with. And if I need more capacity, well, I just add more nodes to that cluster. I keep adding additional servers. Servers, nodes, kind of the same thing. And I keep adding them to my cluster, and I keep building out my capacity. And so the benefits here, the pros to this approach, is that I could use possibly cheaper machines, which might be a better TCO. Replication is built right in. These are designed to be horizontally scaled, which means I get replication with that. It's larger scaling. I don't have to worry about hitting that ceiling. And availability is also kind of built in. So if one of these machines just, the disk drive catches on fire, the other machines can pick up the slack, and it will still keep going. So it's a highly available system. Now the cons to this is that it's distributed. And if you ever tried to do anything with distributed computing, that can be very complicated to maintain, especially if we're talking databases that aren't really designed for that, right? It's something that's very difficult to do, to set up replicas and all the processes that are involved there, and how do you make sure they stay in sync and all those sorts of things. It's very hard to do. And one more thing that's kind of a pro, kind of a con, depending how you look at it, is that the data now, for a distributed system, designed to be distributed, is that our data has to be independent. It can't live in a predefined structure, predefined schema, in order to make it easier to distribute it. So a piece of data can live on any one of these machines, complete isolation, and it can have backup copies on other machines. So if I need to access that data, I can just go directly to that machine and get it. I don't have to go look up through a table or anything like that. It's just right there. It's an individual piece of data. And hence the reason why databases are often using JSON. It's a good format for storing data in a structured or semi-structured way independently. Now, of course, the con here we'll talk about as we go forward is that we get a little more responsibility in having to manage that data. And one more thing with scalability, if we're in a cyclical type of industry where, say, the retail season or the busiest time of year is over for retail, we can scale down and say, okay, we don't need as many VMs because we're not at max capacity, so let's scale down to save a little bit of money with that. And that may be something you do weekly or monthly or 1 month a year or something like that. But it's something you can absolutely do. This gives us some flexibility a lot of ways. Well, the one I want to focus on is that the data is no longer in a relation, so it's not constrained to a schema. And depending on how you look at it, this can be a pro, this can be a con. If your use case can benefit from flexibility, we'll talk about use cases here, that's a pro. Because now I just have a lot more freedom in defining my data. If my use case just needs bigger scaling but not flexibility, it may be a bit of a downside because now I have more responsibility, more work that I have to do in my application to make sure my data is completely uniform, and I want to sort of go against the grain with the flexibility. So that may be a downside, depending on how you look at it, but it's something you definitely have to think about. We'll talk about that in modeling today. Performance is a reason. It's something that's often touted by vendors. Performance can vary widely depending on your use case, the database, and the various measures that you're using. Right? We're talking about under load, how much concurrency can it handle? What's the latency? What kind of durability are you expecting? All those sorts of things. So it can be very subjective. So I'm not ever going to say that NoSQL will always be relational, or that database A will always be database B in performance, because it depends on so many factors. And there are a lot of benchmarks that people publish that compare and say vendor A is great, vendor B not as great, vendor C is terrible. And I'm not really a huge fan of those because, again, there's so many different types of benchmarks out there. And chances are, these are being commissioned and published by vendors. And vendors are not going to publish benchmarks that make them look bad, right? So they're only going to publish the good ones. And hey, lucky number Slevin, thanks for dropping in. Good to see you. Fellow team member of Live Coders. Glad you're here. So performance, I like to focus more on architecture and underlying features that affect performance. Yamami Maladek. Hello, good to see you as well. Thanks for stopping in. Availability is another one. I kind of mentioned this early on. If we have a single database server, and if that server goes down, our application is down, basically. We can't get data. A NoSQL distributed database, it's easier to deal with this kind of thing. So we have, instead of a single machine, we have multiple machines in a cluster, or even multiple clusters networked together over different data centers. And they have redundant data. So just kind of as an illustration here, this is a picture of my wife. I took this picture back when Wonder Woman was in the theaters, back when we could actually go to theaters. Theaters are these places where they showed movies and we all got together in one big room and watched them. And you get snacks beforehand. And so I saw this happening in front of me and I said, this is perfect. I'm going to put this in all my slide decks from now on. If this theater only had the one soda machine here and it's down for maintenance or it's broken or whatever, it's out of a certain syrup, then the whole theater can't get any soda. They can't buy a drink, and so the theater starts to lose money. If the theater, like this one we went to, has multiple machines, they can service one of them while the other machines are still running. And so the customers can still purchase their drinks and can still fill up their drinks before the movie. I think my wife's actually buying water here in this picture. But that's kind of the idea with availability. We have multiple machines to add in some redundancy. And this is for whatever reason. If it's going down for planned maintenance, or if it's going down just some sort of freak accident happens, some sort of crash. And with maintenance, the benefit here is that we can do the maintenance. We don't have to come in at 2 a.m. on a Saturday to do it. We can do it during normal business hours because we can just take that one machine down and work on it. The rest of the cluster is still available. So I believe this is not strictly a benefit of NoSQL only, but I believe that most of the NoSQL databases that are designed for distributed computing are going to do this better and easier. Use cases. So people often ask me, why would I use NoSQL? What are some use cases? What are some examples of using that? So, back 10, 15 years ago when NoSQL was just getting started, the use cases list was maybe smaller than this, a lot smaller. And but NoSQL has changed a lot since then. So if you haven't evaluated NoSQL in some time, it might be time to come back and take another look at it, and just to see what all the capabilities are. So NoSQL isn't always the right choice for every use case or every organization, but it's not necessarily as limited as you may think. So these are some examples of use cases that are only from the Couchbase customer list. They've chosen to share use cases with us. And as you can see, sort of caching, session, even user profile, catalog, and content management, those are use cases where the distributed nature of Couchbase, the built-in caching nature of Couchbase, and the flexibility of JSON really, really shine. And IoT as well. Customer 360, similar sort of data ingestion use cases there. But you can see even towards the bottom of this list, some things like finance are even starting to look at NoSQL databases, where before they might have said, it's too risky, there's no ACID transactions, there's not enough encryption or security features for us. Those things are there now. So go back and take a look. You're going to see ACID transactions. You're going to see role-based authentication, all the sorts of security things that may have made you nervous before. So always, if you're exploring NoSQL, make sure you have the right project or use case. And it always helps to go and find another example of someone who's done something similar. Lucky number 11, I take a hybrid approach when it comes to SQL versus NoSQL. Since NoSQL came about, it's about balancing, using both, but for what they're good at. Absolutely, that's the exact point I'm just about to make here. And I'd say one thing to think about is, there are plenty of companies that are doing these use cases with SQL, with relational databases. But think back to like preschool, where you had the little game where you had to put the shapes into the correct shaped hole in the toy. If you really wanted to, you could probably cram that triangle into the circle-based shape, right? And that's what a lot of people do with relational databases. They just cram the triangle in there. So it may not be the best fit. It may even be a lousy fit, but we're going to make it fit. So NoSQL may be better in some situations. So the catalyst is usually one of those earlier reasons. So performance, flexibility, scale certainly, and availability definitely. And then one more quote here from the Programming Wisdom Twitter account is, if you're looking to improve something, you got to do something different, right? Not saying something different's always going to be the better choice, but this might be worth exploring and at least putting in your mind for like a future project. Oh yeah, maybe NoSQL would work better here. We can give it a try. Okay, so I want to talk about modeling a bit because storing data in JSON is different than storing data in tables. And I'm going to sort of compare and contrast the two. I'm going to assume most people watching are at least passingly familiar with relational databases, maybe not with NoSQL databases. But I want to start with a whiteboard exercise. I drew this myself. I know it looks so amazing. The artwork is incredible, but I actually did draw this myself. So let's look at modeling this. So we're building a new system. We're gathering requirements. We haven't even chosen a database yet or a technology we're going to build it on. We're just whiteboarding out the concepts and say, okay, here's what a customer is going to have to store. Now there are 4 things that I think I want to point out here, 4 properties of this data and of all data, I'd say. There's a rich structure to this data. So we have the customer, and the customer has a name, Helen Mallory. A date of birth, those are attributes. There could be sub-attributes. Nice picture. Yeah, thank you very much. Appreciate that. So sub-attributes might be first name and last name, right? So we could break it down into sub-attributes, but there are attributes there of the data. There are relationships here to other data. So if you look at the connections right up here, we're not going to store customers inside of other customers, right? We're going to connect one customer to another customer. Maybe it's a family account, or when you log into Netflix, you have to choose which user you're going to log into. But Helen is ultimately the one that is the owner of the account, pays the bill, that sort of thing. There's a value evolution. So as Helen makes more purchases, we're going to add more items to her purchases data there. And the last one is kind of a big one. This is kind of the area that I think there's the most difference in terms of data modeling, is structure evolution. So we may look at this and say, okay, well, for our customer data, we need to store a credit card number and an expiration date. Okay, fine. But then a requirement comes down to change that and say, okay, now we need to store multiple billing options for this customer. Okay, well, we can't really store that as part of Helen's data now. It has to be kind of a nested structure or a substructure or related structure to Helen. So we're evolving the structure of the data as we go. Excuse me. And so if you're like me, and I know I am, this is kind of what went through your mind when you saw that data. This is how a schema would look in a relational context, a relational database, SQL Server, MySQL, Postgres, something like that. These are the kinds of structures, the tables I'd want to create to represent a customer. The customer has contacts, the customer has purchases, the customer has connections to other customers. And then when that evolution comes down, well, now we have a billing table. So we have to actually go and change the schema. We have to create a billing table. We have to set up a foreign key constraint from billing to customer. We have to move the data from customer over to billing, and we have to remove those columns from the customer table. So that's at least 4 operations to change the schema that we have to do to make this change to requirements. Now, doesn't seem like a lot, but keep in mind this is a very simple schema. We've got 5 total tables here. I'm guessing those of you who work with relational databases probably have schemas with a lot more than 5 tables, and a lot more complicated things can happen to the schema. And for a large enough data set, changing the schema might mean you have to take the database offline or into read-only mode or something like that. And again, we're back to the 2 a.m. on Saturday. So that is kind of one of the trade-offs you make when you say we're going to follow a rigid schema. Then making changes could have some adverse effects on our system. Now I want you to think about modeling data in a JSON world, and this is kind of a high level. I'm going to take you through an example here. But we should start thinking about grouping the data into something like an aggregate root. So if you're familiar with domain-driven design, kind of the same concept here. In fact, Martin Fowler once said that instead of calling these document databases, we should call them aggregate-oriented databases, which I think is a way, way better name, much more descriptive and accurate, but never really caught on. I'm showing you a table here, but don't think of it like a table. Just think of it like a big collection, a big bucket of data, and then each record in our customer collection there looks like this. So we have some JSON. And notice that we don't have a separate billing table. We don't have a separate connections table, or again, not table, but bucket or collection. It's all built in to that customer. So we've grouped it all, we've aggregated it all into that customer document into one place. So instead of having, potentially 5 different tables and 5 different pieces of data, we've got them all combined into one piece of data in a JSON document. Okay, now let's look how to kind of represent the different things about that. We're going to break that down step by step here. So we'll start with one row of data in the customer table, and that's on the left is the relational model, and the right's going to be the document model. Right here, the translation is pretty simple. We're just storing the same data just in JSON format. Pretty much the same thing. On the left, there's a CBL 2015. That is a primary key, and over here, we're not calling that a primary key anymore. It's kind of a similar thing, but it's a document key. It's the key that corresponds to this document. So kind of a similar process, but not exactly. Okay, if I want to show, now I want to bring in purchases. So in relational database, it's a separate table with multiple rows, one row for each purchase. And then you can see this is a foreign key that links this purchase row to this customer. This is the primary key and this is the foreign key here, and they match. So in the relational database, we've got 2 tables and we've got 3 pieces of data. And then normally to bring those together into our application, we have to do a join operation, or well, it's always going to be a join operation, but might have to go through an ORM, for instance, an object relational mapper, to try to convert it from this flat data into the actual object we're going to use in our language, in our programming, our application. So I like to think of this as you're taking the data from, let's say, your .NET application, your Java application, whatever, and you're going to take it and you're going to feed it through a paper shredder, individual strips, and you're going to store those strips of data. So, oh, this strip has purchase on it, so I'll put that in the purchases thing, and this one says customer, so I'll put it in the customer thing. And then when I want to get that data back out, I got to find all those individual strips and then tape them back together, and then off we go into the application. As opposed to the document database over here on the right, the purchases data is stored in that same document. So this is not a separate piece of data, it's the same document. But notice it's an array there. It's an array of purchases. And there's no foreign key in the purchases because it's not foreign anymore. It's domestic data. Connections. So this is an important concept if you're doing like a many-to-many type of mapping. We're mapping one customer to another customer. In a relational database, we'd often create like a mapping table or a join table, whatever you want to call it, that has this compound key, which is these 2 columns here, that consist of 2 foreign keys. So we're saying we're connecting this customer to this customer. And again, this shouldn't be named. This should be, I gotta update this slide. This should be information about the connection. So this should be like brother or father, something like that. Something about the relationship. In our document database, it's again kind of a similar thing. We have this connections array. So not a separate document, not a separate table. It's an array inside that table, or sorry, inside that document. And then each one of those items in the connections has a ID that connects to another customer document. So we know from here our customer Jane Smith has a connection to another document called SKR007, and that should probably say like brother or something, but maybe her brother's name is Sam Smith. We just want to store that here for convenience sake. It doesn't matter. But a whole separate document with a key of SKR007 is out there that has its own date of birth, its own billing, its own connections, etc. So let's put it all together. Here are the 4 tables on the left, and this is the 1 document on the right. So we've got 7 pieces of data in 4 tables, as opposed to 1 piece of data in 1 document called CBL 2015. So you can see we've got, instead of all the different pieces that go through the shredder, they're all in one place there in the document. Now I've made the rookie mistake here of putting card number, expiration, and card type in the customer table. If I want to add multiple billing options, that's not going to work for me. So we're going to need to go ahead and create a billing table. And so I have to go through all the schema changes I mentioned earlier on. But now we have 9 pieces of data in 5 different tables that we have to join together. And the equivalent over there is the document on the right. Again, we've got, instead of having it at the root level, I've got this billing array that contains that data. Now, one thing I want to point out here, one key difference between these two, and this is something that may make you uncomfortable if you're used to relational data, or you're used to the schema being enforced by the database, is that this document here is CBL 2015. This one is CBL 2016. So, you know, they both say Jane Smith, but kind of ignore that. It should be Bob Jones here, shouldn't it? Yeah, it should be Bob Jones. But they're 2 different documents. They live in the same database, though. So this one has the card number at the root, and this one has the card number inside an array. Those both can live side by side. And this is the flexibility I'm talking about, that these documents aren't related to each other. They don't have to follow the same schema, the same map. At least the database isn't enforcing that. So there's different strategies for dealing with that. You know, you don't want to just go Wild West and have every document look different out there. Of course not. But you may want to evolve your structure over time. With a document database, you don't have to shut down. You don't have to change a schema. You can just start storing different documents when you want to. And then what do you do with the old documents? Well, that's up to you. There's different strategies for how to deal with that. Or some might say more responsibility to deal with that. All right, so that is it. That is my sort of crash course to modeling. But it's important to understand that because we're going to get into what would we want SQL to look like for this data. So we're aggregating it up into sort of larger documents, sort of root level documents, instead of splitting them out a bunch of different tables. Let's talk about the approaches that don't use SQL, which NoSQL databases have more than one approach to read and write data out of them, more than one API. And you're going to use the one that best fits your use case. But the simplest one is key value approach. So we talked about the key earlier. If you know the key ahead of time, just ask the database, give me the document that corresponds to this key. The document returns, or the database returns the document, and away you go. Really, really quick, efficient, simple way to read and write data. And the only problem with this is that you have to know those keys. If you don't, you might want to, if you only have key value access, you're going to have to port your data to some other way in order to access it via key. And that's not going to be super convenient for some use cases. If you can do key access just for one piece of data at a time, this is always going to be the fastest way. The MapReduce I mentioned earlier, this is where you're going to write a couple of pure functions, and they're going to run against every piece of data ahead of time. And as data changes come in, they're going to have to rerun those functions, and they compute the results ahead of time. So and they may be stale for some period of time, or maybe you can enforce, don't make this not stale, things like that. But think it's kind of like materialized view, if you're familiar with that concept. This is great for aggregations, and it's fine when you don't know the key to access the data. You can query it. Basically, you can look at a MapReduce and look by other attributes of the data. And it's really good performance. They can run in parallel. So they're pure functions. They can run completely in parallel, and away you go. It is somewhat limited, though, in what you can write in a MapReduce. Ad hoc is difficult to do because you have to run these functions ahead of time and see what their results are. Unions and joins are typically not possible. Now, we are aggregating our data more, so maybe we don't need unions and joins as much, but sometimes we still do. And again, back to my very first point of the slide deck, it doesn't feel as natural to me to query data like this as a SQL query does. And then I mentioned this, of course, at the beginning. Document databases have some other type of querying language or syntax available. This is a MongoDB example. And this is a screenshot right from the documentation. These languages are somewhat limited compared to SQL, and many developers abstract these behind tools like Mongoose, for instance. Now, Mongo is always improving this language and adding new features, so they're trying to keep up with SQL and the things that developers expect to be able to do. But beyond the raw technical story, ultimately, I think, anyway, this is just an opinion, that JavaScript, using JavaScript or a JavaScript-like language like this, a sort of a imperative language, it doesn't really feel as natural or as powerful as a SQL does. And for many developers who have been using SQL their whole lives to interact with data, this is a tough transition. You got to learn a whole new language, and not only that, you have to convince the rest of your team to learn a whole new language as well. So it could be a tough transition, a tough sell. So I think SQL would be the answer for this. But what would that look like? Let's look at how SQL for JSON should work. And I'm going to use a model as an example here. This is some travel data. We're going to focus just on the airline and route. Ignore the airport and landmark for now. I want to find users. I want users to be able to find flights between given destinations. We used to be able to get on airplanes and travel around the country, travel around the world. I know, crazy, right? But I want to be able to find flights between given destinations on a specific day, sort of things like that. So this is actually a data set that ships with Couchbase. This is why I'm using this as an example. It has airlines, routes, airports, and landmarks. We're just going to look at airlines and routes today. So let's zoom into a route document. There's lots of route documents, but here is one of them. So notice that it has a source airport, and a destination. So that's kind of the definition of a route. It goes from one airport to another. It also has this type field, which I've said is route. That's not a required field. It's not a magic field. It's not a reserved word or anything like that. It's just a convenient way to organize data. So it could just as well be underscore type or doc type or whatever you want to call it. Class, underscore class is what you see sometimes in the Java world. Also notice it has this airline ID field, which you can think of kind of like a foreign key. I've got it in quotes here, though. It's not exactly a foreign key because it's not a constraint, but it is saying, well, if you want the airline, go look up that airline document to get that information. And then the schedule down here is an important thing I want to point out. So this is, in relational databases, this would typically be 3 rows in a different table. It'd be separate from this route, but it's been denormalized into a single document here. So we have the entire schedule for this route available in this route document. And speaking of this airline 24, let's go look at that document. So it's a separate document with a key of airline 24. This is relatively flat data, so no arrays in this one. But also notice it has the name here. So if I want to get that name, I could just go look up this document and pull the name from here. It also has this type field. It's a different value. So I've just chosen to use type as a convention here. As a way to organize my data. I'll split it up by type. So let's look at how a SQL query to access this data might look. And the only part of this query that might look a little weird to you is line 4. A travel sample is not a table. So if you're in a NoSQL database, you don't have tables. Couchbase calls this a bucket. Cosmos would call this a collection, I believe. And there's other different names for it. It's the same kind of concept. It's a bunch of documents. It has route documents, but it also has airline, landmark, and airport. So on line 5, I'm saying, well, just give me the route documents. I only want the route documents. And then line 6 says, just give me the first 10 of those documents. So what would you expect the outputs of this to look like? All right, if you guess something like this, you were right. So you have... You're selecting just the airline ID, destination airport, and source airport, and that's what you're getting. You're getting back an array of the data that you selected. But notice now, we don't really have enough to serve our users because we have this airline ID, airline 137. We can't show that to an end user. They don't know what airline 137 means. So we want to get the airline name. So to do that, we could do a join. And again, if you used SQL before, this should look relatively familiar. Line 6 and 7 is probably the weirdness there, a little bit different. we're joining a bucket to itself, which, joining a table to itself is not unheard of in SQL. But remember that our bucket contains all different types of documents. So this is actually very common. And then line 7, we're going to join the airline ID value. So it's what airline 137 equals, and that meta keyword there. And this could vary from database to database, but in Couchbase, this is how we say the document key in SQL. So we're just joining this document to a document key, or to another document based on its key. Again, kind of like the foreign key constraint, or sorry, foreign key concept. And the end result of this would be what we had before, but now you can see from our query, line 4, we're selecting name. So there on the right, you'll see line 5, line 11, line 17. They all contain the the airline name. So now we can show this to our customers and say, oh yes, there's a route going from MRS to TLV. I don't know what MRS is. TLV is probably Tel Aviv on Air France, assuming they're still in business. I don't know. This is old data. All right, so there we've done a simple join. We've got 9 lines there in SQL that can be read by just about anybody who's written SQL before, or even just read SQL before. And as opposed to a MapReduce series of functions or some sort of other proprietary query language, we have to go through and figure it out and parse through it and do a whole thing. When we already know SQL, SQL is a great language. Let's just stick with it. Aggregation, this would be a very similar thing. So I want here to find all the airlines that have more than 2,000 routes. And again, this is old data. I don't know if there even exist that many routes anymore. But then I'm saying on, this is kind of where the title of this presentation comes from. You can see I'm select, and I'm doing a count. So I'm an aggregate function to count the number of flights. On line 8, I'm having my count, and greater than 2,000. And I'm going to order it by the highest first. So order by count descending. And there you go. You can see only 2 airlines have more than 2,000 routes, American and United. Again, this is old data. I don't know if that's really the case anymore. I'm surprised Southwest isn't on there, for instance. But there you go. And I want to dig into something that's a little more specific to JSON and NoSQL databases. And this is the idea of UNNEST, which I would also call an intra-document join. So let's do another query here. I'm selecting the airline, the destination airport, and the schedule. If you remember, the schedule is an array. So that's what the results would look like. If I blew up that schedule, you'd see it was an array of objects that have day, flight, and time. Let's see a question from Molodek. Is it possible to see execution plans of queries? You're getting ahead of me, Molodek. Absolutely. That is a very important thing. But yes, I will get to that here in a few slides. So here, this is my query, and one of my results, one of the fields I selected is an array. So this is a plain select. There's no join happening here, but one of the fields is an array. And that's fine. That may be fine. You may want to go with that. What I also might want to do is flatten that out. So line 7 here, I'm going to unnest the schedule into S here. I'm going to unnest it into. And this is kind of think of this like a cross join between a document and the array that it contains. Yeah, devs always skip a few steps. Yeah, we don't need to read the whole documentation. Let's skip ahead a few sections. that's right, lucky number 11. So think of it like a cross join between the document itself and the array that it contains. So it's going to decompose that JSON hierarchy and kind of flatten it out. So here's how it would look if I do that unnest. You can see now that the results have kind of blown up here. There's going to be a lot more results because I'm unnesting them. I'm flattening out that array. So it kind of would look better in a table view. Maybe we'll do that if we have time for a demo. There's also nest, which is kind of like the reverse of that. It's another type of intra-document join, but instead of decomposing it, it will encapsulate the JSON. This is also known as join in Cosmos. So if you're using CosmosDB, they don't use the word unnest, they just use the word join. It can be a little confusing, but that's the direction they decided to take with it. So there's lots more examples we could go into of SQL against JSON, but I wanted just to do this quick comparison here that the SQL language operates on a set of relations. And oftentimes we think about relational and we think that means relationships. Oh, relational database, that's because I can have foreign keys and things like that. Well, no, that's not exactly what relation means. A relation, a table is a relation basically. And that's I'm being maybe pedantic here, but that's a key difference between relations and relationships. But anyway, SQL language operates on a set of relations, which are tables, and then projects the results out to a result set, or a type of table basically. And then the result set needs to be mapped to something in the application. We mentioned earlier the ORMs. This could be complicated. It could be relatively simple. And then maybe at some point it even gets mapped into JSON, right? It's for an API endpoint. For our SQL for JSON, we have, instead of a bunch of little tables, we have sort of these bigger aggregate documents here on the left. And we run those through a SQL query. So Couchbase's version of SQL is called NQL, N1QL. So if you're familiar with databases, like SQL Server has T-SQL, Transact SQL. Oracle has PL SQL. Couchbase has NQL, N1QL. There's going to be fewer types of documents because of the aggregation and denormalization. But you still might want to do some joining. So you might want to join a customer to loyalty info or orders to the customer, things like that. And then you go through the joins here in NQL and you get the result, which is going to be the JSON. It's going to be a complex, structured or semi-structured object in JSON. And so you can take that result and serialize it directly into your C# objects or your Java objects or whatever. And you don't necessarily need an ORM here, because there's not a mismatch between the data being returned by this query and the data you're going to use in your application. Here's the Cosmos version. It's a similar sort of thing, but notice that the arrows between the different documents went away, because as of right now with Cosmos, you cannot do joins between documents. So it supports the UNNEST, but does not support the inter-document join. And basically they've said we're not going to support that. So that's what's going on with Cosmos. And just to give you kind of a bigger picture, I can't cover all the SQL syntax today, but I want to show you this bigger picture diagram. So think of this big blue blob here as kind of like an ANSI SQL standard. Now, which standard? Okay, well, we can. That's a question for another day. But maybe it's 92, maybe it's 2016, whatever. But all the stuff you'd expect SQL to do is that big blue blob there. And then this larger blue circle contains a bunch of extra stuff you need to work with JSON. So work with arrays and nested objects and missing fields, things like that. And that's what NQL is. You think of it like a superset of SQL, or SQL++, as I like to call it sometimes. And we're going to talk about the extra stuff here soon. And then just for completeness here, the Cosmos SQL API, it's kind of one foot in both worlds. So it's not going to cover the whole SQL standard, right? There's no insert, update, delete, merge, for instance. And we already discussed there's no join. But it does have extra stuff to deal with JSON, because there's still going to be nested arrays or nested objects and arrays in Cosmos SQL. Extra stuff for JSON. So we don't have to go into huge detail on this, but because there are arrays and nested objects, we need some additional features to deal with that. So I want to point out there, second to last row, nested traversal. So if we have a nested object and an object nested in that, we need to be able to address those. So we add dotted syntax, select x.y.z. That'll get you all the way to z. Or if we have an array, we want to select a specific item from the array. We say array, give me the first element of the array, a bracket 0 bracket. We can range over those collections too, the very first line there. So we don't have to pull out an individual array element. We can range over the whole array collection, for instance. And then missing. So earlier when I showed you that example where one document had billing array and one document had billing data at the root of JSON, if one document has fields that the other documents do not have, we can use the missing keyword here to search for those. So if document A has first name, last name, document B has first name, middle name, last name, we can find examples of both of them. We could say where middle name is missing or where middle name is not missing. And then we can make some decisions about, do we fill it in with data? Do we process it differently in our application, that sort of thing. So that's one way you might want to deal with that. So lots of other stuff going on there, dynamic construction, filtering, unset, which is something that's kind of weird when you first learn about it. You know you have update set x equals foo, where you can also unset and completely remove that field, which just doesn't make sense in a relational field. All right, now let's get to Molodek's question here. Questions about indexes. So indexes are just as important, if not more so, than relational. So I know I'm guilty of this when I would code with relational databases. If I'm just creating a smallish table, I'm not gonna beat myself up if I don't create an index for it. Oh, whoops, I forgot to create an index. Not a big deal. If I have to scan the whole table, it's a small table. It's not gonna hurt anything. But back to the NoSQL world, all of those documents are in one heterogeneous collection. So if I have to scan the whole bucket, the whole collection, that could be a huge amount of data. So we want to avoid scanning the entire collection, the entire bucket. And that requires careful indexing. Now, one of the things you can do if you want to just take a shortcut, you can say create primary index, and that allows you to scan the whole bucket. All right? We can create what's called a primary index, which is basically turning on table scan and saying, I don't care about performance. I just want to get the query working. Not recommended for production, but a useful development tool. Down there at the bottom, I have a more useful index. I'm just indexing the type field. You can see at the bottom, I'm creating an index named def type, and it's on the travel sample bucket, giving it type. Now, that's a very simple index. You can also add compound indexes or multiple fields so that you can have covering indexes, functional indexes, partial indexes, what's called adaptive indexes, which are a little more efficient way of dealing with unknown queries or ad hoc queries than the primary index. Can be a lot more performant. So I'm not going to go into indexing here much more than this, other than to say indexes are crazy. Your question was about execution plan of SQL queries. There's probably no point in indexes. Well, as you're going to see here, it's absolutely important to think about indexes. So if I'm going to look at this query here on the left here, I can put an explain in front of it, and then I can get out the results on the right. And that is the query plan. And you can see which index it's using. And so if it's hitting an index you expect it to or not, that's going to be important to factor into your performance. So that's one way you can do it. And this is in Couchbase. I think the explain command might be in Cosmos. I'm not 100% sure about that. But it'll give you certainly a different output. But then, of course, depending on which tooling you're using, you can also visualize that index. So this is a Couchbase plan visualization, like you'd see in SQL Server or whatever other tool you're using, that shows you all the different steps of the query and what's taking up the most time. Is it using the correct index? Right here, the fetch step seems to be the slowest. 37.9% of the query is on fetch, which makes sense. So maybe this query is as good as it's going to get. Or maybe we can skip the fetch. If we want to use a covering index instead, we can skip this fetch step, for instance, depending on what we want to do. But yeah, plan visualization there. So you can look at the raw text, you can look at the visualization, and make decisions about how to tune your queries. Very important. All right, we're coming up towards the end here. So I want to show you kind of a comparison here. We've got your standard relational SQL in the first column, or the middle column, and SQL for JSON, and all the different features about them, and how they're kind of similar and how they're kind of different. So obviously at the bottom there, we're working with tuples, working with relations in the SQL world, with NoSQL working with JSON and sets of JSON, arrays of JSON. You have data types that are, in SQL you have lots of different data types. Although for me, I think just make everything varchar 5000. That's the easiest way to go, right? That's a little joke for you there. Hopefully you're not doing that. But yeah, you have varchar and int and small int and all those types of things. With JSON, you have the standard JSON data types, right? You have number, string, null, boolean, object, array, things like that. Okay. And then a quick comparison of NCL, which is Couchbase's language, and Cosmos's, which is Microsoft's Cosmos SQL language. And this has changed a little bit over the years. Cosmos has actually added in some things recently. to put more yeses in their column. But you can't do an insert, update, delete, merge with Cosmos. You do those with other operations, with key-based operations. As I mentioned, you can do an intra-document join in both. It's called UNNEST in SQL, and it's called join in Cosmos. You can't do an inter-document join with Cosmos, but you can do that with SQL. With NCL, it's called join and nest. Aggregation is now there in both. Until recently, Cosmos didn't have that. And you can do sprocs, triggers, and UDFs, kind of in both. So they're called those things in Cosmos. In Couchbase, you have UDF, and you have something called events, which are not exactly like triggers, but you can respond to data that's changed or deleted with some JavaScript code that you write. A mix of JavaScript and SQL. Okay. And one more quick point to make is that, and again, I can direct you to some other resources if you want to learn more about this, but databases are kind of converging a little bit these days. So relational is getting features that are typically more like NoSQL features and vice versa. So I spent a lot of time talking about how SQL has been added to NoSQL databases. But it's true that they're adding JSON to SQL databases. So Postgres, for instance, is probably the leader in this. You can have a Postgres JSON-B data type, and you can do some operations on that. Microsoft SQL has JSON support. I don't know if it's a data type or it's just a series of functions. But I can show, there's a blog that my colleague wrote, Dennis, who is much more knowledgeable about Postgres than I am, and he compares Postgres JSON handling to, well, basically he's comparing SQL 2016 to SQL++. So sort of the pros and cons of each approach. All right, we're coming up towards the end here. How are we doing on time? I've sort of lost track. It's about 5 o'clock now, so I think we're doing okay. Yeah. So they say you only remember about 3 or 4 things from any given presentation, so here they are. Number 1 is pick the right application. If you're trying out NoSQL, make sure you have a good high-level reason to try out NoSQL. You're going to make a proof of concept probably. You're not just going to dive in, but make sure your use case makes sense for NoSQL, that the benefits of NoSQL are going to benefit your use case. JSON data is modeled differently. So you got to think about embedding versus referencing and try to group as much as you can possible into a document. As opposed to relational, where you try to split it out as much as you can. It's kind of the opposite approach in a way. And I say, just in general, we don't need to abandon SQL as a query language. Even in the NoSQL world, let's bring SQL and keep it as the standard that it is. And we're going to query NoSQL with SQL. All right, so of course I want to encourage you all to download Couchbase and try it. But if you don't want to download it, if you just want to play around with NCL, with SQL, you can do that here. Go to this first link here, NCL query. It's spelled a little differently. N1. It's not N1QL. That's the name of the language. But this bit.ly link is the actual word NCL. And that'll take you to an interactive web page where you can go through and learn about NCL in an interactive way. And just, it's like a sandbox environment where you can type in SQL queries and play around with it. And Cosmos has a similar site. I haven't checked it in a while. I hope it's still there, but bit.ly/CosmosSQL, you can kind of go through an interactive exercise of writing Cosmos SQL in a browser. You don't have to, do the normal thing where you pay for your Azure account and use that to try it out. NCL is based on this academic effort from UC San Diego called SQL++. And this was a paper that they produced, part of the Forward project. So you can go learn more about that at the bottom of the screen there, bit.ly/UCSD_SQL. But NCL is pretty much the first implementation of that SQL++ paper, validating that paper. And so that's a very cool piece of research and work that they've done that Couchbase has started to run with. One of the inventors of SQL, the SQL language, is Don Chamberlain. This is him right here. Raymond Boyce is a co-inventor. He's no longer with us, but Don still is, and he has written a book called SQL++ for SQL users. He is actually a tech advisor to Couchbase. So it's really awesome to work at a company that believes in SQL enough to bring in one of the inventors and ask him to to weigh in and help provide guidance. His book's available on Amazon if you want to check that out. It's also been made free as a PDF from Couchbase. So if you go there to free SQL book with underscores between those words on Bitly, you can get that book. It's a relatively short one. It's not going to, it's not like a 500-page tome or anything, but it's a very interesting book written by the creator of SQL. And he's been in some videos as well recently. NoSQL and SQL++, two sides of the same coin. Some really interesting and funny bits of conversation in that video. When he was first thinking about JSON data and SQL, it was just, it didn't really make sense to him at first. And then he just kind of started thinking about it more. And one of my favorite quotes is that JSON data kind of looks like tables if you squint, which it's hilarious. But you can check out those videos there. So SQL Coin and Language Panel on Bitly links. I'm no Don Chamberlain, but you're welcome to use me as a resource as well. I'm on Twitter, mgroves. I'd love to talk with you on Twitter if you have a quick question or looking for resources. And I'm, of course, I'm happy to jump on a Zoom call or something with you if that's what you'd like to do to discuss it further. Since we're not in person anymore, I can't discuss with it out in the hallway. I'm happy to do that with you virtually. I'm also on Twitch. You can see the link right down here at the bottom of the screen. I stream around twice a week, maybe sometimes more, sometimes less. Not always about Couchbase, but usually about back-end stuff, database stuff, ASP.NET, .NET Core, things like that. And if you have technical questions about Couchbase, or if you just want to see what other people have asked and found out about Couchbase, go check out forums.couchbase.com. All right. So I think I want to wrap up here. Oh, looks like my chat is still kind of working. Someone just followed me. I appreciate that. So that's not this channel's chat. That's my own channel, Matthew Groves Streams. Thank you very much for that follow. I appreciate that. That's pretty much all I've got here. These are some questions I get asked a lot all the time. So I have slides prepared for them. I absolutely click one of these if anyone in the chat is interested. Happy to follow up with those. But I do want to say thank you very much to Manning for giving me a slot on the channel. It's very cool that Manning is supporting live coding on Twitch, and I love it. And supporting their authors as well. Even though, I wrote my book was written 9 years ago. They're still supporting me as an author. So very cool. Ryan, thank you very much for your feedback. I appreciate that. Thank you for hanging out. So anybody interested in any of these topics here, these questions I get asked a lot, happy to click on those and explain more. So just drop that in if you have other questions as well, besides these, just drop those in the chat as well. Happy to answer those. Manning's given me additional time if I need it. We're not up against the clock or anything, so happy to hang out and talk about this stuff. Number 3, I get asked a lot in person mainly because I'm a very tall guy. I'm 6'6", but I am very, very bad at basketball. I don't know why height is associated with good basketball play because it takes a lot more than that, right? I'm super clumsy and uncoordinated when it comes to sports, so not my game. Hard word 1. Thank you very much. Thank you for coming. I appreciate it. Appreciate that emote or that emoji. All right. Yeah, thank you very much for the follows, everybody, and subscriptions on YouTube. I appreciate that as well. Yeah, if you want to check out some of my older videos, a lot of this stuff I've covered in more detail on older streams, bit.ly/GrovesTube. You can check that out there. If you were around early before the stream for the pre-show trivia, that's actually something that I've built using Couchbase as a back end as well. That's a relatively new thing. And I just thought I would throw it up on the screen. For the Manning channel as well. So, all right. Well, I don't see any more questions in there, so I just want to say once more, thank you very much, everybody, for attending and hanging out. And make sure to give Manning a follow as well. If you scroll down below the video here, you'll see links to the great content that Manning's put together and future sessions that are coming up. And there may even be a coupon code down there. Hopefully, I'm right about that you can use to purchase Manning books at a discount. The great thing about Manning, I think, is that you get when you get a digital copy of the book, it's DRM free. That's super handy. You can just take that book and put it on any device you want to very easily. One of my favorite things that Manning's done. But Manning's always doing some great stuff. The books I recommend, so mine is AOP, which is not related to anything I talked about today. But if you're interested in aspect-oriented programming in .NET, I think it's still a useful book, even though it's 8, 9 years old at this point. Certainly, if you're into C# and .NET, I'd recommend checking out Andrew Luck's book, ASP.NET Core in a nutshell, or something like that. I can't remember the title. It's over there on my bookshelf, and I'm straining to see it. But Andrew Luck is the author I'm talking about. And then, of course, John Skeet has a C# book. I think it's in 4th edition right now. C# In Depth, another excellent book by an excellent author. So definitely want to check those out. So thank you again to Manning. Thank you, everybody, for watching. I'm going to go ahead and shut down the stream now. But hang around for Manning and check it out for upcoming presentations by other authors. So thank you very much. I hope you all have a good day.